Okay, in the introduction we saw how to develop the double angle identities. And so here we have the 5 identities that we found in that video. And so now we're going to take and apply those. Notice they do have a proof of the double angle for sine here, and it's just what we went through in developing the identities. So, evaluate expressions involving double angles. We have the sine of theta is 3/4. We want to find sine of 2 theta, cosine 2 theta, tangent 2 theta. So we're going to go to the double angle formula for sine of 2 theta. The double angle formula is 2 sine theta cosine theta. And so we run into just a little bit of a snag here in that we need to know the cosine of theta. Well, we see we are on the interval from 0 to pi over 2. So we're just going to make a little drawing like we often have and say, okay, we know we're up in the first quadrant here and that sine is 3/4. So we have 3 and 4 there. And using the Pythagorean theorem, then the other side is the square root of 7. So now we can proceed to fill in. So we have 2 times the sine of theta, which is 3/4, times the cosine of theta from our triangle. We get that is the square root of 7/4. And just a little arithmetic to simplify that. We have 3 square root of 7/8. Moving on to the cosine of 2 theta. We could go with any of the 3 formulas. Let's go with the cosine of 2 theta equals 1 minus 2 sine squared theta. And I choose that one because we were given the sine of theta to begin with, so it's not using anything that we weren't given to begin with. Plugging in, so we have 1 minus 2 times 3/4 squared, or 1 minus 9/8, and 1 minus 9/8 is negative 1/8. So that's telling us something there also. We now know that this angle 2 theta is in the second quadrant. Otherwise, we would not have come up with a negative number for the cosine there. To find the tangent of 2 theta, we could use the tangent identity, or we could use the sine cosine. So we have tangent of 2 theta is going to equal the sine of 2 theta over the cosine of 2 theta. And we've already found both of those. So sine of 2 theta, 3 radical 7/8 over negative 1/8. And that gives us an answer of negative 3 radical 7. So our 3 answers: sine of 2 theta, 3 radical 7/8, cosine 2 theta, negative 1/8, and tangent 2 theta, negative 3/7. Next, we look at solving an equation using these formulas. So we see that we have a cosine 2 theta in the equation here, and we can't work out an equation that has both a cosine 2 theta and a cosine theta. So we're going to take and change that cosine 2 theta, and we have 3 choices for the identity we're going to use there. Because we have cosine in the other part of the equation, we probably want to use the 2 cosine squared theta minus 1 formula. Making that substitution then, we have 2 cosine squared theta minus 1 minus cosine theta equals 2. As always with this type of equation, we next want to take that and put it in a descending order and set it equal to 0. So if we add the 2 to each side, We have 2 cosine squared theta minus cosine theta minus cosine theta, no squared there, minus 3 equals 0. And we're ready to factor. So here I've used the box method to factor that, and I get that it factors into 2 cosine theta minus 3 times cosine theta plus 1 equals 0. So now we're looking for where does the cosine of theta equal 3/2 or cosine theta equals -1. Well, we should notice right away that cosine of theta cannot equal 3/2 since cosine oscillates between -1 and 1. So cosine theta equals -1, and that occurs when theta is pi. So our answer, theta equals pi. Now try this example of solving an equation on your own. And you should have found that the answer is B. How long will that go on?